Hello and welcome to this lecture in which in the previous lecture we have discussed about the parameters which are causing the stresses in the different components under the working conditions. So in the last lecture we have seen the loads and different types of the loads and how they will create the stresses in the component in the working conditions. So in this particular lecture we will be discussing about the moment and couples. So moment and couples are also the different types which will cause the bending stresses or any turning effect, so the torsion effect, and that's why we have to understand these two parameters in order to calculate our examples. Okay, so let's start with the first topic, that is the moment. Moment is something which is the measurement of the turning effect which is caused by the force on the particular body. So let's consider a body, and if the force is not passing through the axis of the body and it is acting at some particular distance, then that particular force will try to rotate the body, and this rotation can be measured using the moment. Okay, and that's why we have to formalize the moment, and for that formulation, consider a force which is acting like in the upward direction like this. And we want to find out the turning effect of this particular force on a point, let's say a point which is shown in a figure like this. Okay, and so we have to find out the line of action of the particular force, and the line of action is shown by the dotted line which is extended in the line of the force like this. Okay, now the line of action of the force is having the perpendicular distance x from the point of consideration. Now, if you consider the point which is situated at the x distance from the particular force F, then the force will try to rotate the body in the clockwise direction like this. Okay, and if we want to find out the moment, and if we want to formalize the moment, then the moment can be formulated like m equals to force into perpendicular distance, that is x. So the formula of the moment will be m equals to force F into x. Now this formula contains the x. X is nothing but the distance from the point of consideration and line of action. So this distance changes will create the change in the value of the moment, and that's why the moment depends on the point of consideration. And that's why whenever you take another point of consideration on the plane where the distance, perpendicular distance of the force is changing with respect to the point, then the value of the moment will also be changing. Okay, so this is dependent on the point of consideration. Now let us consider the another parameter, that is couple. Now the name itself indicates that it is a combination, it is generated with the combination of the two different forces. So couple is generally formed by two equal and opposite forces, but whose line of action is different. So whenever you consider to formulate the couple, if you consider the force which is acting horizontally right side and another force which is acting horizontally left side, so these two forces are basically equal, having the equal magnitude and opposite directions. But as you can see, the line of action of both of these forces is different, and that's why we can say that the perpendicular distance between these two line of action is x. So the moment can be calculated for this particular force by the equation m equals to force into distance x. So this is the formula of finding the moment generated by the couple. So couple is nothing but the combination of two different forces, and these two forces will also try to rotate the body in a clockwise direction. And that's why the measurement of this particular rotation can be calculated using the equation m equals to f into x. So this is the simple basic formula of the couple. Now as you can see, the formula of the moment generated by the couple and the formula of this moment generated by the single force is same. So what is the difference between the moment and the couple? So the couple is not dependent on any point of consideration. So we can say that the couple is continuously or constant throughout the plane on which it is acting, And we can prove this by considering two different points. So consider first point, which is situated at x1 distance from the upper force and x2 distance from the lower force. So if you consider that particular point, then we can calculate the overall moment by algebraic sum of the moment. This is nothing but the principle of moment. Okay, so take the moment of the first upward force by considering the point of consideration at x1 distance. So if we apply the equation of the moment, that is nothing but the force into perpendicular distance. So here the force is F, upper force is F, and the perpendicular distance is x1. It will try to rotate it in the clockwise direction, and that's why we will consider it as a positive F into x1. Now, another force is the lower force. This lower force will also try to rotate in the clockwise direction, and that's why if we apply the equation of moment, that is F into x2, it is in a clockwise direction. That's why we have considered both in the positives with the positive sign. Okay, so now as you can see in this equation, the F value, the forces, both the forces, upper and the lower forces are the same, and that's why we can take them out as a common. And if you take them out as a common, then our simplified equation would look like F into x1 plus x2. Now, if you consider the x1 and x2, summation of x1 and x2 is nothing but the x. So if you replace that value, x1 plus x2 can be replaced by x. So our final moment answer will be F into x. So we have calculated the moment using the principle of moment for this point of consideration. Now if you consider another point of consideration on the right side, at a distance of A from the upper force and at a distance of B from the lower force. Now we will calculate the moment for this point of consideration, and we will try to find out the equation of the moment for this particular couple. So let's say for the second time we will apply the same method, that is nothing but the moment of the upper force. Upper force is trying to rotate it in the clockwise direction, and if we apply the equation of moment, that is F into A, that is F into A plus lower force is also trying to rotate it in the anti-clockwise direction, and that's why if we can calculate the moment of the lower force as a F into B. Again, the force F is common here, and that's why we can take it out as a common, and the rest of the equation will look like F into A plus B. Again, the summation of A and B distance is nothing but x. So we can replace the A plus B as x, and the final equation of our moment will look like F into x. So we have taken two different points of consideration at x1 and x2 distance, at A and B distance, but for both of that particular point of consideration, we have got the answer of the moment of the couple, that is F into x, as a constant. So we can say that the couple is not dependent on any point of consideration. If you are applying a couple on a particular plane, then the value of the moment of the couple will be the constant on the entire plane, but that for that particular plane only. If you are calculating the value of that couple on a different plane, that will be the different. Okay, so this is the basic difference in the moment and the couple. So the moment is dependent on the point of consideration, because whenever the point of consideration changes, the value of the perpendicular distance changes, and that will change the moment answer. And the couple is not dependent on the point of consideration. That's why the moment of the couple is constant. Okay, so this was the basic difference between the moment and the couple. Now we will see another parameters, that different types of the moment that can be encountered in our example or day-to-day life, so that you have to identify that particular moment in order to calculate the stresses. Now consider a cylindrical body which is fixed on the one side and another end is free. Now if you consider the two different forces which are applied on the another end or the free end, that these two forces are applied on the circumference of the cylinder. Okay, so if you consider these two forces, it will try to rotate the body in an anti-clockwise direction. Okay, but the body is fixed on the one end, and that's why the body cannot be rotated, and the result of this kind of application of these two forces will create a couple, and this couple is having the nature of anti-clockwise direction. But due to the fixed end, the body will not rotate, but instead of that, the twisting effect will be narrated in this scenario. And this twisting effect is nothing but the torsion effect. Okay, but this torsion effect is generated by the moment of the couple, and this moment of the couple is generating the twisting effect, and that's why this type of a moment is known as a twisting moment. Now, in order to find out the twisting moment, we will apply the simple concept of the couple only. The couple can be calculated using the formula F into perpendicular distance. Here the force is applied as a F, and the perpendicular distance between the two different forces is the diameter of the cylindrical body itself. And that's why if you want to find out the twisting moment of that particular couple, that twisting moment will be T equals to F into T. This is our final equation of a twisting moment. Now there is also another custom in which we represent the direction of the twisting moment, so that we can understand the effect of that particular twisting moment in our working condition. So the direction of the twisting moment is anti-clockwise, and that's why we will apply an anti-clockwise arrow after the equation or after the value of the twisting moment, so that we can understand, or a designer can understand the effect of that particular twisting moment. So this type of twisting moment will create a shear stress in the body, and that's why it is also important to identify while calculating the example. Now consider another effect. We are applying another couple for which the force F is applied like on the free end like this, and on the fixed end like this. These both forces are applied at a distance of L. The perpendicular distance between the two forces is L. Now, these two forces will try to rotate the body in a particular direction, but due to the fixed end, the body will not rotate in that particular direction. And due to this rotation, due to this fixing of the moment or the body, it will try to bend the body like this. Okay, it will try to bend the body like this. If the body would be free, then the body would rotate like this. The body would be rotate like this. Okay, and this rotation is nothing but the clockwise direction rotation. But the body is fixed, and that's why the rotation is prohibited. And due to the prohibition of the rotation, the effect of this couple will be the bending effect. It will try to bend the body like this. Okay, and this effect, due to this effect, we will call this type of a moment of the couple as a bending moment. It is nothing but a bending moment, and bending moment can be represented by the M. Now, in order to find out the bending moment, we will use the basic concept of the couple again. That is, bending moment M equals to force, that is F, and perpendicular distance between the two different line of action of the forces. And the perpendicular distance is nothing but L. That's why our final equation of the bending moment will be M equals to F into L. Now again, here also we will apply our custom. As per the custom, we will apply the direction in the beside the value of this equation. That is nothing but the clockwise direction, and that's why, as you can see, we have provided the arrow beside the equation of the bending moment. So this is the final equation of our bending moment. Now this bending moment will try to bend the body, and due to this bending, the body will suffer the bending stress into it. So this is also another important moment to be identified in order to calculate the bending stress. Now, this bending stress will be dominant in the case of the beams and gears design, and that's why we have considered this topic very important before starting the introduction of the stresses. Okay, so in this particular lecture, we have seen the difference between the moment, couple, and we have seen two different types of the moment, that is twisting moment and bending moment, and their effects in the particular working condition. So that we will be starting the different types of we will identify the stresses in the upcoming lecture. Till then, thank you.